Hello dear students, in this video I will continue with Unit 5 Inferential Statistics. Here I will discuss about hypothesis, degrees of freedom and the steps involved in t-test for one sample. In my previous video I have discussed about population, sample, different types of sampling methods and confidence level. I have also discussed about sampling distribution. Here we will see what is standard error of mean. The standard error of mean, it measures how much dispersion there is likely to be in a sample's mean compared to the population mean. So this standard error of mean, it is nothing but it is the standard deviation of sampling distribution about the mean. Sampling distribution, as I already mentioned in my previous video, now similar to probability distribution, which gives various values of the random variable and the associated probabilities. Sampling distribution, here it will give the sample statistic data for various samples. Say if we have sample 1, sample 2, sample 3, sample 4, etc. And here let us say the sample statistic is the sample mean. That is x1 bar, x2 bar, x3 bar, x4 bar and so on. This standard error of mean, it measures the standard deviation of this sampling distribution about the mean. And this standard error of mean sigma n, it is given by sigma m is equal to sigma by root n. Here this is up to etc. n, where n is the sample size and sigma is the standard deviation of the sample mean. So here, now what is the use of this standard error of mean? If this standard error of mean, if this is very small, it means the standard deviation about the mean, it is very small. Either sigma is very small or we have n is very large. As a result, if we have a small standard error of mean, it gives us confidence that our estimation of the population means is relatively accurate. So we should have a very small value for this sigma m. And now if we have a large standard error of mean, it means we are having a small number of observations and they vary a lot and the population estimation is likely to be inaccurate. So this is the use of standard error of mean. This is standard deviation about the sample mean. Now coming to hypothesis. Now if we want to conduct any test, the first step is we have to write the hypothesis. Now what is this hypothesis? In order to make decisions, it is useful to make some assumptions about the population. These assumptions, it may or may not be true and it is known as hypothesis. So when we want to draw conclusion about a population or when we want to study a population, then we have to make some assumptions about the population. Those assumptions are called hypotheses. These assumptions are written as tentative declarative statement about the relationship between two or more variables. And now there are two types of hypothesis. One is the null hypothesis and the other one is the alternate hypothesis. The null hypothesis, as the term indicates null, it means neutral or which is common to everyone. So that is basically the null hypothesis. The opposite of null hypothesis is the alternative hypothesis. So the null hypothesis, it is denoted by H0 and alternative hypothesis by H1. The null hypothesis states that there is no difference between the parameter and a specific value or there is no difference between two parameters. So here H0 is a statement of no relationship. As I already mentioned, It is a common statement or it is a neutral statement. That is the reason why we have this term null. So it is a statement of no relationship. Usually it states that there is no difference between a parameter and a specific value. Here in my previous video I have explained what is parameter, what is statistic. All those characteristics which pertains to the population is a parameter, and all those characteristics which pertains to a sample is called statistic. So the null hypothesis, it states that there is no difference between a parameter and some given value, or there is no difference between two different population parameters. It explicitly says that two groups we are studying are the same. Now alternative hypothesis is just the opposite of null hypothesis. It states that there is difference between a parameter and a specific value, or there is a difference between two parameters, or it says that the two groups we are studying are different. Here null hypothesis says two groups we are studying are same, or the value of the parameter is equal to a specific value, or there is no difference between two parameters. So if you see, all these statements are neutral statements or null statements, whereas the alternative hypothesis just states the opposite of null hypothesis. It states that there is existence of difference between a parameter and a specific value, or there is a difference between two population parameters, or it says the two groups that are under study, they are different. Now this is with respect to hypothesis. Now we will see how to write the hypothesis. Here is an example. Suppose a cake is baked through conventional method, has an average lifespan of mu days, and it is proposed to test a new process of baking cakes. So here it is given, a cake is baked through conventional methods and it has an average lifespan of mu days, and it is proposed to test a new process of baking cakes. Now it means the researcher is going to test a new process of baking cakes so that it will improve the average lifespan. So that is the aim of this test. It is to test whether the new process of this baking cakes, it will have an average lifespan different from mu days. So the null hypothesis will be the neutral statement. So the null hypothesis will be there is no difference between the average lifespan of those cakes baked through conventional methods and those baked through the new process. That will be the null hypothesis. And the alternate hypothesis will be that there is a significant difference between the average lifespan of the cakes baked through conventional methods and those baked through the new process. So this is how we have to write the null hypothesis and the alternate hypothesis. Null hypothesis H0, it states there is no significant difference between the average lifespan of cakes baked through conventional method and those baked through the new process. That will be the null hypothesis. And the alternative hypothesis H1 will be there is significant difference between the average lifespan of cakes baked through conventional method and those baked through the new process. If the lifespan of the cakes baked through new process, if it is equal to, let us say, mu1, then the null hypothesis H0 will be mu equal to mu1, and the alternative hypothesis H1 will be mu not equal to mu1. So this is basically null hypothesis and alternative hypothesis. Now moving on to the next topic, degrees of freedom. It is nothing but it is the number of independent pieces of information on which an approximation is based. So the number of independent pieces of information which are available and about which an approximation is done, it is called degrees of freedom, and it is denoted by nu. This is nu. We have the population mean given by mu. This is mu, whereas this is nu. So the degrees of freedom is denoted by this symbol nu. Now what is this degrees of freedom? Let us understand with examples. Here consider a classroom having seating capacity of 30 students. So if a classroom has got a seating capacity of 30 students and the number of students are also 30, it means we have 30 minus 1 equal to 29 students. They are having an option to choose the seat where they can sit. Whereas the last student, he has no other option. He or she has to occupy the only seat left. So here the degrees of freedom is 30 minus 1 equal to 29. So the degrees of freedom short form is DF. So it is 30 minus 1 which is equal to 29. Here let us take another simpler example. Pick a set of 3 natural numbers whose sum is 60. So here we have to select any 3 natural numbers whose sum is 60. Say for example, we can select 10, 20. If we select 10 and 20, the third number that we have to select is 30. Only then the sum will be 60. So here the degrees of freedom is 3 minus 1 which is equal to 2. Again similarly if we choose some other numbers, let us say 15 and 20, here the other number that we have to choose, it is so like that. When we want to pick a set of 3 natural numbers whose sum is 60, the first 2 numbers we are free to choose, whereas the third number it is restricted to the conclusion that we have to make. So here the degrees of freedom is 3 minus 1 which is 2. So this is with respect to degrees of freedom. And now moving on to level of significance. Now what is this level of significance? Usually while conducting a test, we have to write the null hypothesis and the alternate hypothesis, and we conduct the test to see whether the null hypothesis is true or not, whether we can accept or not. Now there may be some cases where we will make a wrong decision. So that wrong decision, it is given by level of significance. So the level of significance is the probability of making a wrong decision when the null hypothesis is true. Or in other words, it is the probability of rejecting H0 when H0 is true. So that is with respect to level of significance. And now moving on to one sample t-test. So whatever we have studied so far, the hypothesis, the degrees of freedom, the level of significance, all these will be applicable in this t-test. There are various steps involved in conducting this t-test. So while writing the steps, we will understand each of these concepts in a better manner. Now we will see what is one sample t-test. This t-test, it was developed by a researcher by the name Gossett, and since he was not allowed to publish his research, he used a pen name student and he published this t-test. So it is famously called student's t-test, or the statistic is called student t-statistic. So this student, it is the pen name of an author or the researcher who developed this t-test. Now coming to the meaning of this t-test. The t-test is a statistical test for the mean of a population and is used when the population is normally or approximately normally distributed with an unknown variance. So here this one sample t-test, it is basically used to test whether the mean of the population, it is equal to some given value, or if there is any significant difference between the population mean and the sample mean. To find all these, one sample t-test is used. This one sample t-test, it is used to test whether the mean of a population parameter is equal to some value or whether there is any significant difference between the mean of the sample and mean of the population. So for these purposes, one sample t-test is used. And the assumption that is made is, here the population is normally or approximately normally distributed with an unknown variance. If this is the case, then we can use one sample t-test. Now let us see the t-statistic for this test. Let x1, x2 up to etc. xn be a random sample of size n from a normal population with mean mu and variance sigma square. So we have a random sample x1, x2 up to etc. xn of size n with mean mu and variance sigma square. This sample is from a normal population. Then the student's t-statistic, it is given by t is equal to x bar minus mu upon capital S by root n, where x bar is equal to summation I is equal to 1 to n xi upon n, and we have this S, it is given by S square is equal to 1 by n minus 1 summation I equal to 1 to n xi minus x bar the whole square. This is nothing but this is the sum of squares of deviations from the mean. So S square is given by 1 by n minus 1 into summation I equal to 1 to n xi minus x bar the whole square. This is not the sample variance. The sample variance is given by small s square and it is 1 by n summation I equal to 1 to n xi minus x bar the whole square. So this is the sample variance, whereas this s square, it is an unbiased estimator for the population variance sigma square. Now these unbiased estimator, all these things need not be complicated. So let us just remember this formula. In my next video, I will explain how we can use the sample variance to find the test statistic t. So t is given by x bar minus mu upon s by root n, where x bar is the sample mean and this s is given by s square equal to 1 by n minus 1 summation xi minus x bar the whole square. Mu is the population mean and n is the sample size. Now coming to the procedure for testing the hypothesis by using the t-test. So the first step is we have to state the hypothesis. So we have to state what is the null hypothesis H0 and the alternate hypothesis H1. And then the second step is define the statistic. So we just now saw the student's statistic, it is given by t equal to x bar minus mu upon s by root n. That is the second step. The third step is sometimes the value of t can be negative. If x bar is less than the population mean, then the value of t will be negative. In that case, we have to find mod t and we have to find the table value of t with n minus 1 degrees of freedom at alpha level of significance. So similar to the normal distribution table, we have a table to find the value of t for n minus 1 degrees of freedom and for various levels of significance. And then the fourth step is we have to make the decision to accept or reject the null hypothesis H0. And finally, based on the information that is given in the question, we have to summarize the results. Here one important thing to note in this step, make the decision to accept or reject H0 is, here when we have to accept H0 and when we have to reject H0. When the t value, the calculated t value, if it is less than the table value. If the calculated t value is less than the tabulated value of t with new degrees of freedom at alpha level of significance, then in this case we accept H0. On the other hand, if the calculated t value is more than the tabulated value of t, in this case we reject H0. Here accordingly, based on the decision that we have made, we have to summarize the result. All these steps will become familiar as we solve a number of problems on one sample t-test. Now let us understand this with an example. This example I have taken from Applied Mathematics Class 12 by D Sharma. In my next video, I will solve the exercise questions on t-test from Applied Mathematics Class 12 by D Sharma. Here, a random sample of size 16 has 53 as mean. The sum of squares of the deviations taken from mean is 150. Can this sample be regarded as taken from the population having 56 as mean at 1% level of significance? So here it is given the size of the sample is 16 and the sample mean is 53. Then the sum of squares of the deviations from the mean, it is 150. Now we have to test whether this sample is taken from the population having 56 as mean at 1% level of significance. So here alpha is 1%. So first let us write what is given. Given the sample size n equal to 16 and sample mean x bar equal to 53 and then the population mean is 56. Mu equal to 56. And then one more thing which is given is the sum of squares of deviation from mean. It is 150. That is summation xi minus x bar square. This is equal to 150. Now for finding t we need s. So let us find the value of s square and keep it here. So s square equal to 1 by n minus 1 summation xi minus x bar the whole square. So it is equal to 1 by 16 minus 1. This summation xi minus x bar square is 150 into 150. So it is 1 by 15 into 150 which is 10. So s square is 10 which means s is equal to root 10. Root 10 is 3.16. So we have found s also. Now the first step. Step 1 is writing the hypothesis. Now we have the null hypothesis. Here it is given, can this sample be regarded as taken from population having 56 as mean? So we write the null hypothesis. There is no significant difference between sample mean and population mean. That is, we regard this as being taken from population having 56 as mean. And then we have the alternative hypothesis. There is significant difference between sample mean and population mean. So this is the alternate hypothesis. Now coming to step 2. The second step is we have to write the test statistic t. The test statistic is given by t is equal to x bar minus mu upon s by root n. So this is equal to, here x bar is 53, mu is 56. 53 minus 56 upon, we just now found, yes, it is 3.16. 3.16 upon root n is 16. Sample size is given as 16. So it is equal to minus 3 into root 16. When we take it up, it is 4. Root 16 is 4. So minus 3 into 4 upon 3.16. It is minus 12 by 3.16, which is approximately equal to minus 3.8. Now we are having a negative sign. So we have to take modulus t. This implies mod t equal to 3.8. Now the next step is finding the table value. Here the number of degrees of freedom is n minus 1 will be 15. So degrees of freedom nu equal to 16 minus 1, which is 15, and the level of significance alpha is 1%. So alpha equal to 0.01. So we need to find t value for 1% level of significance with 15 degrees of freedom. We have to find this value. Now this is the t distribution table, and it gives those critical t values. It has got first row area in one tile, second row area in two tiles. Now we are not concerned with area in one tile, so we need not be concerned with these values. We are only interested in area in two tiles. So here the degrees of freedom is given. So we have the various degrees of freedom and the area in two tiles. Area in two tiles means it will give the critical value. If it is 0.01, then all these values will give the table value of t at 1% level of significance for different degrees of freedom. Here all these values will give the t value for 2% level of significance and different degrees of freedom. All these will give the various t values for 5% level of significance and various degrees of freedom, and so on. So here we have to see this row. So here we have to find the table value for t, the critical t value for 1% level of significance and 15 degrees of freedom. So this is 1% level of significance, and here we have 15 degrees of freedom. So the value is 2.947. So the table value is 2.947, and the calculated value is 3.8. Now we have the third step. Mod t is 3.8 and tabulated value is 2.947. So here we can see that mod t greater than the tabulated value. So we have now when this t value is more than the table value, it means we have to reject H0. Step 4 is reject H0 at 1% level. Now what we have taken as the null hypothesis? The null hypothesis is there is no significant difference between the population mean and the sample mean, but here we got the decision to reject H0. So finally we have the last step. Hence the sample is not taken from the population having 56 as mean. So whatever is asked in the question, based on that we have to write the null hypothesis and the alternate hypothesis. After getting the decision, that is whether this t value is more than the table value or this t value is less than the table value, accordingly we have to reject or accept H0 respectively. So and finally we have to write the sentence as given in the question, except that we have to see to it that whether we accept or reject H0. So here the conclusion is the sample is not taken from the population having 56 as mean. So this is how we have to go about with the steps when we use t-test. I hope this video was useful for you. Thank you for watching.